C is a piecewise curve. It's composed of a line segment first joining the origin to 1, 1. You could call that C1. And then a quarter of a circle with parameterization. I'm going to call it R2 of t. There's going to be an R1 of t as well. Cos t, negative sine t plus 1. T between 0 and pi over 2. Where would this quarter circle be? Think about plotting points. When t is 0, cosine of 0 is 1, sine of 0 is 0. You'd be at the point 1, 1 when t is 0, which is right there. As t increases, cosine decreases. There's the cosine. And negative sine t plus 1, what does that look like? It's actually like this. They both decrease. You're going to be moving this way. It's like this. There's C1, say, there's C2. The goal is to find the line integral over C, which consists of both curves together. C is C1, then C2, you might say. Or even C is C1 plus C2. We're adding curves in a sense. It's actually somewhat standard notation. And the way you do it, when you do the line integral of f of s ds over C, is you effectively define it to be the sum of the line integrals over C1 and C2. It's essentially a definition. Use parameterizations for both of those. Now we have a parameterization for this one already given to us. R2 of t is cos t, comma, negative sine t plus 1. The understanding is the parentheses go around the t there. We will need its derivative, which is negative sine t, negative cos t, and we need the magnitude of that derivative, which fortunately is constant, 1. We also need a parameterization for C1. Call it R1 of t. That's not given to us, but we can figure it out. It's this line segment right there. We could use t comma t for that, as t goes from 0 to 1. Its derivative will be 1, 1, and the magnitude of its derivative will be square root of 2. So to do these integrals, you use those parameterizations, you plug them into the function, and integrate over the appropriate intervals. In this one, this parameterization, t goes from 0 to 1. And this other parameterization, t goes from 0 to pi over 2. Simplify as much as you can. This is a square root of 2. This is a 1. That's nice. What is f of these things? It depends on what f is. In problem 10, f is given to be x squared plus y squared. F of xy is x squared plus y squared in number 10. That would mean f of R1 of t, there's R1, effectively is f of t comma t. T squared plus t squared. 2t squared. That's what goes right there. And f of R2 of t, plug those things in for f for x and y, is f of cos t negative sine of t plus 1 I've got to square those and add them. Cos squared t plus, I have to square this thing. I have to FOIL it. I'd get a sine squared t minus 2 sine t plus 1. That's a 1. So this all simplifies to 2 minus 2 sine t. And that's what would have to go right there. And then you do the integrals. They would not be too hard, but probably it looks like the square root of t, 2 is not going to go away. The answer is probably going to involve the square root of 2.